Thank you so
Yeah.
much.
Okay. Yeah, I think it's all good now, Albert. We'll start in 7 minutes time.
Okay, no worries. I'll just sit back and hang back. Sit
All right.
and hang back. I guess, is there any way that I can see the audience?
Test, 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 test. Hello?
Hello? Yeah.
Test. Oh. Still low. Test. Testing. Test. Test. Okay. I think it's good.
Yeah, that's much better.
Testing. Good afternoon, everyone. Welcome to our panel session for today. Search naturally. How can AI help us sift through our noise? This panel is going to be talking about examples of how we can make use of large language models to easily learn about our data. This panel will be presented by Albert Shim, a front end engineer that that also infuses AI into products. Without further ado, Albert, let me pass the floor to you.
Okay, thank you very much. Hi everyone, thank you for taking the time to join myself today. So I'm going to be talking to you today about searching naturally with LLMs. So for those of you who are interested in taking a copy of the slides or you want me to follow through, please, I'll give you a few seconds to scan the QR code. Okay. Right, now let me begin. So what does it mean to search naturally? So to answer the question, I'm going to introduce to you something called semantic search. So semantic search is a method where you can search using everyday language and phrases, and the system understands the context and meaning behind your words to provide relevant results. So here on the right, you can see I have 4 examples. What is your favorite food? What do you like to eat? Which type of food do you enjoy the most? What's your preferred choice of food? So all these, sentences written differently, all pretty much have the same sort of meaning. So how is this different from, traditional search? So when it comes to traditional search, it's keyword based. It has very limited understanding. It doesn't actually interpret the meaning of the words. It's very sensitive to spelling mistakes and typos, and it definitely will not recognize synonyms. So if we had a database full of food names of food, if we search for the word nasi, pretty much 1, 2, 3 we know will show up in a search result. If we introduce some form of fuzzy string search, even maybe number 4 will show up if we had a mistake in our database where nasi is labeled as masi. But we can definitely be certain that if we had fried rice in our database, it will not show up when we search for nasi, simply because it just doesn't know that. So being able to understand the query or the question that the user is asking is only one part of the equation. So imagine, you're having a conversation with a friend and you ask them, what is your favorite food? So it's very natural for that person to answer in different ways. One example would be, you go to Instagram, you look for the food, and then you show them the picture of the food. You use an image to, answer the question. Or you could actually come up with a story about your last visit to this restaurant where you found your most favorite food. So it's very conversational and it's very natural in that sense. So asking a very simple question that any human language will answer and then responding in a way that a human will answer. So that human machine interface that we think of in the past is now slowly moving, or not so slowly, but very quickly moving towards a stage where it's becoming more natural. And with the advancements of LLM, it's also making this much more accessible than ever before to introduce this kind of elements into our products. So for today's discussion, I'm going to talk through 4 different things if I have the time. I'll start with looking at unstructured data using the Brunei Legislative Council handset as an example, and then we'll look at structured data using a 5G survey, and then I'll briefly look at what it means to give tools to LLMs, and then we'll end with what we can do next with this. Hey, let's begin with unstructured data. So what is unstructured data? For those of you who may not understand the meaning of this, it refers to things like textbooks, emails, social media posts, audio, web pages, things like that. So with this example, here are some key facts about the Legislative Council handset. It's primarily in Bahasa Melayu. It's shared on the website in the form of a PDF. And if you combine all of them together, there's about 1,092 pages. Just in case you're not sure what the handset is, it is a written transcription of the entire parliamentary session held during the LegCo. So this year it spanned over a period of 18 days. Therefore, that written transcription of 18-day session translated to 1,092 pages in PDF. So there tend to be a lot happening in those documents, you see. And we normally, for the regular people, we consume snippets of this information in the form of social media, news media, and things spread from friends and families. So this only really represents the highlights. It's a very, very small fraction of the 1092 pages of content that we actually have. So this scenario is not just possible in this. This is not the only scenario. This happens a lot with day to day. As students, we write reports, we read large textbooks. We can only really extract bits and pieces. It's very hard. We may not have the time or capacity to actually read through the entire document. So I'm going to go through a brief example, a brief demo, where I built a product, a simple product using OpenAI to read and communicate with the handset. So in the interest of time, I may not necessarily have time to actually go through this properly, but here, very simple chatbot UI. So I started with a very simple question of, what is the whole of nation approach? So we hear that a lot. So based on the information that were talked and mentioned about during the lecture, so this is how we answer the question. The whole nation approach is strategy described by so and so, and here we outline a few different things. For example, in enhancing grassroots leadership, the approach is geared towards enhancing leadership as explained by the Ministry of Home Affairs. And here we also have the reference. So this reference kind of means that this was mentioned during the 6th day of the lecture during the morning session, and it was a 29th speech. So here you can see it went through, it picked up information from different parts. So here we have the 17th day, the 6th day, and here also on the 2nd day, as mentioned by the penasehat has. Yeah. Okay, then here we have another example. I was asking for name some new developments in the Ministry of Health. So once again, we went through if I didn't ask this question, I would never have imagined all the new things that are happening. Right. So here there's a launch of the picture archiving and communication system and the construction of several health centers. The start of a construction of a new emergency services building. Completed by the middle of the year. Okay. So these are all information that we very easily extracted once you've got the setup. So the first two examples I've asked in English, but now I can also ask in Malay. Contoh cabaran-cabaran Kementerian Pembangunan. So because I asked in Malay, it also responded to me in Malay. So it gave me some examples. Here, there's quite a few. Let's say, for example, masalah banjir di Jalan Bukit Dilit dan Jalan Raya Namarai yang mempengaruhi rumah-rumah di zon 3 dan zon 5, terutamanya semasa hujan lebat. So yeah, we went through, answered the question, and then now that it's identified some of those key problems that were mentioned, we can actually ask some follow-up questions like, okay, sebagai warga negara yang baik, bagaimana saya boleh menolong mengatasi cabaran tersebut? So then, using that information that identified, it outlines some key things that I can think about. So I'm not going to go through all them, but for example, menggalakkan kesedaran, membantu meningkatkan kesedaran dalam kalangan komuniti tentang pentingnya penyelenggaraan dan kebersihan dalam sektor. So these are quite interesting things that we may not normally think about, but the LLM really helps and does a lot in this area to help us spur creativity or just think differently. Okay. All right. So that's done there. So you might be wondering, so how did that work? So the way that was set up was through a method called retrieval augmented generation, or for short, call it RAG. So it's very simple. We start with a question, how do I do X? And based on that question, we look through our knowledge base. In this case, the knowledge base is the answer. We look for the relevant information. And then using that relevant information, we give it back to the LLM. And the LLM will use that to generate an answer for us over here. Okay, so to go through that step by step, firstly, we have to be, I'll introduce you to what we mean by embeddings. So embeddings, as you see on the right here, it is a numerical representation of the strings of text that we introduce into, our kind of we translate our text into numerical representations. If you don't understand what it means that if I have a string of text here, what is my favorite food? That will be translated into this string of numbers. Same with my favorite food is nasi lemak. This also is represented in this form. So numbers are what the machine understands. And we go through the entire handset and we convert all of that into these embeddings. Okay. So once you've converted them, we actually need to start storing them in vector databases. So vector databases has been around for a while, but it's only recently because of the change advancements in LM that it's become a bit more mainstream. Okay, so there's a lot of different examples here that you can use. So once we've stored our embeddings, now the next part we need to conduct what we call a calculation of cosine similarity. Don't worry, I won't go into details about the math behind it, but it's essentially just a dot product of two vectors. So if you look at the bottom left here, what we're trying to identify is essentially when we take two strings of text, we compare it. If we see a small angle, small cosine angle, that means that these two pieces of text are quite similar to one another. In the calculation, if it comes out to be something big, then we know that those two information are likely not related to one another. So once using this cosine similarities calculation, we can identify the relevant pieces of text that we need to feed back to our LLM. So here on the right is a very simple representation. So in the LLM, we give it some information, some instructions. Using the context below, please answer the question. So here we have three pieces of text that we extracted as being relevant. And then using this, please, the LLM will answer what has been mentioned about emergency services. Right? And that is how we arrive, that's what's happening behind the scenes for this chatbot. Okay. So in summary, for this particular question of what advancements has been made in aquaculture, the first step was to actually translate that piece of text into Malay, which became apakah kemajuan yang telah dilakukan dalam aquaculture di Brunei. So this translation is then used to create an embedding, and then with all the other texts that were already stored in our vector database, we retrieve similar texts here, as we saw here, these three different texts, and then the LLM will use this information then to reword and rephrase in a much more natural way that we can read and understand. Okay, so I don't know about you guys, I hope that seems exciting to you. So here were some other things that were done for us to get to this stage. So because the document was in a PDF, we had to translate that into text or markdown to ensure that the text is a lot more readable and much more organized. For those of you who have some experience with OCR, you'll know that it's never perfect. The next step was we needed to extract some metadata as well, things like who the speakers were, which section of the handset this text came from, and we had to do some pre-processing. So one of the things with working with LLMs is that the number of token count or the word count is something that is kind of like a limit. We cannot just throw the entire handset into the LLM. There's a limit. We can at most use about 5 pages maybe at a time. So we summarized it to reduce the token count. Okay, so one key limitation here is that it is only as good as the textual representation of the document. So on the right, you'll see that when I did the PDF to text conversion, you'll see that it's kind of in a mess. The line breaks unnecessary, right? There's a lot of spacing, and this is somewhat okay. Sometimes it becomes even worse. So we do have to correct this. And keep in mind that in your conversion step, if it doesn't handle images, then images will just, if you have an image of a table, that will be translated to nothing. So those kind of information will get lost if you try and do basic PDF, to text conversions. So today we can actually do a lot more in that area. There's a lot of computer vision or vision enabled with the ability to extract complex images. For this example, we do not. Okay, so if you're interested to look at the full Malay and English handset, you may refer to this website here. But you can get this at the end of the presentation. Okay. Now, for the next part, let's look at structured data. So what is structured data? So this normally refers to things like databases, CSVs, Excel documents, survey forms, sales data, or things that we normally consume through APIs. So they're all pretty much structured data. And as developers, we mostly work with structured data. So for this example, I've taken some data from the National Data Sharing Platform for Industry. at nadi.pm. So you can go there and you can retrieve the same data set. So it was a survey that was conducted in 2021 on the topic of 5G. So some key facts about this is that there were 700 respondents as an Excel document with about 23 fields and columns. So normally when we do our surveys, we get this data, and then Google Forms does very well by quickly giving us some charts to demonstrate the outcome. And otherwise, we will go into Excel or Google Sheets, and then we'll build our own charts and analyze according to kind of like a preset question that our manager came to us with. And whenever the question changes, if you didn't have the chart ready for it, you would have to rebuild it again. And you have to set up all kinds of complex filters if you really wanted to dig further into it. So here, this is what the survey form result look like. Just a very standard Excel Google Sheet table. And then on the website, we have this example that was provided. Do you require 5G service? And it gave us the percentage distribution of the people who answered this question with maybe, no, and yes. So typically static output. So if I wanted to know more, or I had other kinds of questions around this data set, like who were the people who thought that 4G alone is sufficient? Okay, so now I'll show you another demo, again using OpenAI, but also using an open source repository called Wishful Search. I'll give the link to this at the end of the presentation. Here, all right, where is it? Okay, over here. All right. So here again, 700 rows of data. I've converted the CSV into JSON format. And here we have a sample of one row of the data. So coming back to the question, people who are only 4G. So just by typing, a very just basic sentence, and I can see from here that there are 82 results in total. And here I've just configured it to always show me the distribution of the age range of the respondent. Okay, pretty cool. I hope so. I think this is pretty cool. And then let's say I wanted to change it to non-government individuals that only need 4G. Okay, and that has now reduced to 54. So just a quickly scan, you can see that the answers in the employment sector, they're all private sector, self-employed. So we know the query is done correctly. And how about like students willing to pay more for 5G? Okay. Yeah, so you can see here, age range here, pretty much students 35 and below. And there's 18 individuals who are willing to pay more. Interesting. All right. So yeah, so that's a quick example of how we can use natural language to search for structured data. So how did that work? How do we get there? So very simple. We've essentially used an LLM to generate SQL queries. So I won't be explaining what an SQL query is. I hope people in the audience here understand SQL. Oops, I skipped too far ahead. So the first step here is to take our CSV, convert it into JSON, and then convert it into a database schema. So this is pretty standard for most databases. So here on the right, you can see I have a very simple SQL statement. Create table, survey responses, ID, age range, employment, and they're all in a text format. Yep, pretty straightforward. So this is a very flat table. And then we continue to describe the meaning of each column. So the ID is just unique identifier. The age range, we can explain that this is the age range of the respondents. And employment, this is employment sector of the respondent, so on and so forth. So we give some meaning to all the different columns so that the LLM will know that this column refers to this. And when we ask the question, it knows which column to use as part of the query. Okay. So the last part is to generate the SQL. So here, again, coming back to the OpenAI example, using database schema below. So here we provide the entire schema so it knows what it's referring to. And then we define some rules, do not use limit, listing, so on and so forth, prefer sorting, and then provide an appropriate SQLite query to return the keys. And then give the actual question user, the individuals who are not interested in 5G. Right. So just look at what SQL queries were generated. Here I asked, has good knowledge in 5G. So this translated to select ID from survey where 5G knowledge like very good knowledge. So it's smart enough to know that that particular column has a few set of repeated data. So it's very good knowledge, little knowledge, or no, so on and so forth. So it used that to write this query such that it can pick out only those with good knowledge. And then here, another example, people in logistics are interested in 5G. So it went on to pick from the column of the occupation type, where it's transport and logistics, and then also for the require 5G services column, it picked yes. Right? So essentially, the LLMs can now write SQL queries for us. Amazing, right? So here's the next interesting thing. We know that we can translate natural language into SQL queries, and then we can also now provide the results from that database back to the LLM and say, okay, the user asked this, these are the results. Give me a score. Did the results actually answer the question of the user? And if it passes the score, or if it's too low, decide whether or not we should expand or reduce on the filters such that we can improve the result to better match the question provided by the user. And in doing so, ask the LLM to write a new SQL query so that it can better answer the question. So here in this example, I've asked the question of the most tech-savvy respondent. So this is super subjective, super like, in the traditional sense, it will be super hard to answer this question. So the first step, it went, okay, select where 5G knowledge, very good knowledge. So order by 5G knowledge, we kind of know it's not really useful, but here it works. So it has translated, tech savviness to being someone who has very good knowledge. And it gave us 148 results. So the next part, it then analyzed it. It saw that the result is somewhat suitable as it provides information about the user, the responder with very good knowledge. Okay, so it can be interpreted as that. And what did the user actually desire? So the actual user wanted to know about respondent who is most knowledgeable about technology, specifically 5G. And the user might also be interested in the opinion and attitude towards 5G. So based on that, it decided that a better filter would be to also consider respondents who work in the tech-related sectors, and also those whose organizations are at a much more advanced stage of digitalization, and also those who have a positive attitude towards 5G and the potential benefits. So it translated the question of the most tech-savvy respondent to becoming who is the most tech-savvy respondent considering their knowledge about 5G, their occupation, the digitalization stage of the organization, and their attitudes towards 5G. So this is an updated query. And in this updated query, it came back with only 2 results. So it has refined it to help us narrow down the responses which could best answer this question. Okay. All right. So some extra things that were done here to help to improve it. I haven't touched on the concept of few shot learning, but essentially that's just providing some examples to the LLM of how we can translate certain queries into SQL statements. And where we have in our data set where the columns have only a fixed number of data, it could be yes, no, it could be high, low, medium. So those things we can introduce as static or dynamic enums such that the LLM won't try to look for different words. When it's yes or no, it won't try to look for true and false. So these things greatly improve the performance of the translation from the user query to a SQL query. Other things to note as well is that for this particular wishful search repository, it's only geared towards doing basic selects and joins. So when it comes to aggregating data and whatnot, those are not included yet. And lastly, we do have to go through our own step of converting the CSV or the Excel into a JSON, and subsequently, the wishful search report itself will help you in converting the JSON to a actual database table schema. So you do not have to write any SQL query at all. Okay, so here's a link to the repository. So big shout out to my CTO who wrote this library for everyone of us to try. All right, so just to kind of like bring all those things together, those concepts together, let me introduce to you, LLM with tools. So what does that mean? So today, like the large language model, you can view it as an assistant with a set of tools. So when a user asks a question, we can give it different functions, different tools. So if we change that handset retrieval tool, and we describe it as a tool that can fetch such and such information to the LLM, and then we can also translate the survey retrieval, bot into another tool as well. And we tell the LLM that these are the tools at your disposal. Use it if it's relevant to what the user is asking. So here, depending on the kind of question that's being asked, the LLM will then decide, okay, do I need tool 1 or do I need tool 2, or actually I do not need any of them. Provided that we label and describe the tools appropriately, it is very good at deciding which tool to use. And then subsequently, with the responses from those tools, it will update this context and then answer the question of the user. So, this really here is the beauty of what LLM can do. You can connect as many tools as you want, describe what you can get out of the tools, and then let the LLM do what it needs to do. And next thing about this is you don't actually need to retrain anything. So you don't have to go and collect large data sets just to train the model, just to do this specific task. You only need to describe the tools at its disposal. Okay. So I didn't have the time to, create examples from this, but I do have something that's already out there that you guys can try later on. So here is an example chat application where I have, 5 different tools set up. The first one is I have a Google custom search API. And then, I have DALL-E image generation, also have image to text conversion. And there's also a kind of like a chat with PDF. So if you upload documents, you can chat with it. And there's also speech to text. So what this LLM does is based on what the user asks, it's going to look at the set of tools that it has, and then it's going to answer accordingly. Okay, so here is an example. So it's a Telegram bot. Ask, please locate the best nasi natok. So it's actually a typo. Clearly, I wanted to write nasi natok. So given that this is a query that kind of needs like real and live information about where we can go for certain things, and it knew that, and it went to search, on the web, and then it gave us references to where it found what it thought was the best nasi kotak. Here, it recommended for us to go to the STK restaurant in Rimba. It's a couple of nasi kotak variations, and then another option would be to just try nasi kotak salase at the Pasar Malam. So because of my typo, the LM was trying to like, okay, is this person really asking for that or that? So it also then taught me a new thing, which actually natok is a Bangladeshi term for telefilms or drama. And it actually gave me suggestion for a Bangla natok title, Mona Arale. I'm not sure if I'm pronouncing that right, but yeah. So it looks up the web for this information. Okay. So then I asked in the query, I need a plan on how to start a business selling nasi kotak. So here, it kind of knew that it didn't necessarily need to go onto the web to search for this information. It could answer this using its own internal knowledge. And then it proceeded to tell me, okay, here are some things that you can consider when I'm trying to sell nasi kotak. Right. So if you're interested to try this, it's free for everyone to use. It's a Telegram bot. Again, you may scan this or you can wait to the end of the slides to get access to the bot. Okay, so from all of this, what can you do next? So I do hope that you're all as excited as I am when being introduced to this kind of technologies. Like, hopefully you've got the creative juices, running, and you kind of imagine what kind of information you have and what you can now start to infuse some LLM into it. You could start by building more things with unstructured data that you have, whether it's research documents, operating manuals, standard operating procedures, homework, legal documents. You can look to Google's Model Garden, which has very easy to use APIs for you to generate embeddings. So that's the first step, generating embeddings and then finding a suitable vector database to use. So Google's Model Garden also have a lot of open source LLMs. So in my examples, I use OpenAI, but there's also other good alternatives like Mistral, like Llama 2, that you can swap out instead. Okay. Then next we have with structured data. So the example that I use is data that I obtained from nadi.bn. There's a lot more data sets there uh, of different kind of like sizes that you can try. And then we also have Kaggle. So Kaggle has a very, very large repository of data that you can just hook up, do wishful search, and start going crazy. In the wishful search repo is an example where we utilize the movies dataset from Kaggle. So it has like thousands of metadata information around movies, and you can very easily use that to decide what you want to watch. And then whatever survey forms you have, whatever sales data you have, and there's also a lot of like open government data from UK, Singapore, to name a few, that you can now try and hook up and build something from there. Okay, that brings me to the end of my slides. Thank you so much for your time. And yeah, please feel free to scan this to go through the slides and get access to all the links that I shared.
Okay, thank you, Albert. Does anyone have any questions? We have a mic here. I can pass it to anyone that has any questions. Okay, we have one question coming, Albert.
Yep.
Hello.
Hello.
Okay. So I have an issue about privacy because you say you're using OpenAI LLMs, right? So how did
Yes.
the privacy matter for like the data sets?
Yep. Okay, great question. So for the very first example, when it comes to the handset, so that is essentially a publicly available document, so we don't have to be too concerned there. So for the next one, when it comes to structured data, so you'll find that we've actually abstracted away the data from the actual SQL query writing. So the only things that we're passing on to OpenAI is the statement from the user, and we're trying to convert that into SQL query. The data itself is not connected to OpenAI. So that is one level of like separation from being afraid of exposing your data to OpenAI. However, if even the query that the user is asking is actually considered to be sensitive and shouldn't be exposed, then that's kind of the step where you need to start looking at open source models, where you need to run your own instance and deploy it. And a lot of it is kind of like replaceable. You may just need to adjust the prompt a little bit, but that will keep your data from being exposed to the outside world. Hope that answers the question.
Yeah. Thanks.
Does anyone else have any questions to ask?
If you guys have any questions about like the handset or whatnot, I can do a live demo now using that.
Actually, I have a question myself.
Mhm.
So, I'm not that technical oriented, but I'm kind of much more interested in like the use cases of this AI
Mhm.
and search engines, right? So, part of my work, at least part of what I'm doing, is we're trying to see how we can connect. And sorry. So, uh, okay, maybe let me step back a bit. Give some context. So I quite like I'm quite fascinated, right, when you can use AI to create that MySQL code, right? And basically, all of a sudden, you augment the business intelligence side of things with AI and make it really easy to create reports and stuff.
Yes.
So, but you've mentioned there data aggregation is not considered in your methodology. So I was
Mhm.
wondering, maybe I just kind of want some of your thoughts. Is it possible to use AI to like connect and aggregate multiple different data sets that are in different formatting or different standardization and put them all in one single document with the same formatting? So basically, to create data governance using AI or to enforce data governance, something like that. Is that
Mhm.
possible? Thank you.
Yeah, yeah, definitely. Like, I mean, like a year ago, I think the answer to that question would be, please wait another 10 years. But today, that is very, very possible. I think the only thing stopping that from happening is really just you do need to put in effort to establish those different transition points. So we do still need to, like, I guess, if you think of the different tools or them as different agents, depending on the data set that you start with, you need some kind of like translator to get it into that final output that you desire. So, you know, right now we are taking the handset and we're taking the output in a way that it's conversational, but we can easily change that to generate like a table of data. And the same, you can do the same thing for all the other data sets. Here's the data, get this output, now translate this into something else. You can define the schema of what you want to translate into, and it's pretty good at that. And then once you get all these different kind of like data sets with its corresponding translators, you can then aggregate it in the way that you want it. Whether you can do it manually aggregation or you can use an LLM to aggregate the information. Yeah. So you just have to kind of like set up the, kind of like what we call the AI operations pipeline, AI ops or AI pipeline to process all those different things at various stages.
Okay, thank you.
Hmm.
Does anyone else have any questions? Okay, then I do have another question.
Yeah, feel free, feel
I'm
free.
kind of geeking out now. So I don't know much about AI, right? And you've mentioned about this AI operations pipeline and the need for a translator, something along those lines. Can you
Mhm.
elaborate a bit more of what AI ops is?
It okay, it's very general, so it can encompass a lot of things, I suppose. But
Okay.
it's slightly it's how would I explain it?
Okay, maybe just to narrow down the question, right? In the context of this, the question that I asked for to
Mhm.
aggregate the data, where would AI ops play? What kind of things would an AI operator do? Wait, if that's the word. Thank you.
Yeah. I guess if we start from the very beginning, you kind of have to identify where the data sources are and how you can extract those information. So, if they're all just Excel tables, distributed around different files, you need to bring them together. And then you'll need to figure out how to access and consume those Excel data. And like the thing that doesn't change between now and before is that you still need to do some data cleanup. Um, the only difference is last time maybe you had to do the cleanup manually, but now you can actually use AI to clean up data. So an example of how AI was used in the handset was that when we did the PDF to text translation, the formatting was all over the place. And we previously in the past, you would get someone to manually go in there, remove the spacing, press the enter to give the new lines and so on. But now you can just give that to the AI and say, please fix the formatting. And it does that for you. So that kind of like AI pipeline would mean that you have to introduce different things like that within the data flow, whether it's cleaning up the data, translating the data to a different format, and then eventually saving it in a database somewhere. So that's kind of like the preparation of data set. And then in the actual consuming of the data, then it depends on the different user interfaces that are actually consuming the data. So if there's some kind of like, feedback retraining loop where, after a while you realize that the AI that you built doesn't really answer the question, but you know how to overcome it. So then you need to collect that feedback loop, go it back to the LLM. And I didn't touch much about training here or retraining of data, but that would represent one part of the flow as well. How do you collect feedback and use that to retrain the model such that it can give better answers? And yeah, so that flow kind of like goes from where you first source the data all the way until how you consume the data. What is also very important here is actually testing and figure out whether or not the answers that the LLM or the AI churn out is safe for the user. And yeah, there's all kinds of different things you have to do there as well. Yeah. So interesting enough, sometimes people also use the LLM to check the output of the answer to deem whether or not it's safe or not safe. And if it's not, then we have to again, go back to the cycle of changing our prompts, introducing more data, or removing data to make the product better.
Okay, I
I
see.
don't know if that kind of answers the question, but
No,
yeah,
it does. It does. So I have a vague idea of what it is, but you've basically validated it. So I actually kind of see it now. So thank you very much, Albert. Really appreciate it.
yeah, you're welcome.
Does anyone else
Okay.
have any more questions they would like to ask? Oh, right, there's one.
Hi, good afternoon. My question is like, I know about AI and MLs. Is it like a machine learning algorithm that you're talking about? It's like, training is needed for any algorithms to work, right? In a machine algorithm, we have like unstructured, structure, clustering, classification, a lot of things going on. So what you're
Yeah.
talking is like no training is required. So how will
Mhm.
the the machine will know like, oh, go here first, something something like, usually AI works by training, right? So what you're saying is like no training required. So
Mhm.
is it like a machine learning algorithm that you're talking about, or is it like totally out of machine learning or training? So getting that question, even though my knowledge is limited, I'm still learning stage of AI and ML. So what you're saying is like out of the training part and like the algorithms part. So or where does this stand, like the search naturally part? Do you get
Yeah.
my question?
Yeah, I do. I get a question.
Okay,
Like, it's a very good question. So, here's the thing that I think a lot of people don't realize has happened late last year is that so AI ML tend to kind of like be this discipline that only a certain group of highly intellectual individuals can participate in because there's so much like technical things to do and that what happened there was you tend to need to spend a lot of time and effort to collect data, to train data, to answer a very specific domain related question. Um, and where this is prevalent a lot is, in the financial sector. There was a lot of machine learning associated with trying to predict how the market moves and whatnot. And that is like one subset of AI ML that has been around for a while. So now with the introduction of large language models, the way the training happens is a little bit more different now. And there's a lot of people out there who have developed and trained these LLM models such that it, it is almost at the stage where it is so good that we don't actually need to do any more training on top of it. And this varies in like the kind of models out there that you retrieve. So OpenAI is a very good, it's like the leaders in this area now that the LLMs that they've developed and allowed the public to use, although yes, you have to pay for it, um, but it's at that form where it is so intelligent that you really do not need to add anything more on top of it. You can use it as it is. It's a brain that is now exposed as an API that you can tell it give it all kinds of instructions and it can answer them. It can do things with it. So when I say that no training is required, it means that we're just taking someone else's already trained model and then we're using it as is. So almost immediately this becomes accessible to like, yeah. So and there are different levels of large language models that are out there. So OpenAI is closed source, but there's a lot of open source models out there that you can actually, if you have a good enough computer, you can actually download those models and run them on your machine. And what that looks like is you can talk to an AI without internet on your computer, and it can help you do all kinds of things. So
Okay,
that's
so we
kind
are
of like
we are
where we have reached.
better with the AIs and without training. Got it. Thank you.
Yes, that's right. I'm sorry about the question. I answered a bit long, but I hope you understand.
Okay, thank you, Albert. Does anyone else have any questions? So we have one here as well.
Mhm.
Hello again. So I
Hello.
have some because I usually have trying to develop an app using LLM for quite some time, and the thing that is like a part of it is something to do with prompt engineering. So
Mhm.
as someone who really like to break things, I tend to learn about you can use prompt to kind of break the system a little bit, and
Yes.
it's really a fun thing. But I'm really curious, like if you have like a business and stuff that is built for like very sensitive data and all, and let's say some like bad actors using prompt engineering to get like really valuable sensitive data, like how are you gonna combat that?
Mhm. Yeah, so very good question. I have honestly with our company, we haven't really worked with that level of sensitivity of the data yet. But I've talked to people who has. So yeah, I think first of all, it's very important for the company themselves to kind of like instill that mentality in them or the kind of rule set for which they when it comes to working this data. They have to be very strict about it. So it can come in many forms. Um, but essentially there's the people part and then there's the technical part. And as we all know, usually it's the people part that goes wrong, right? But when it comes to the technical part, um, we tend to have to introduce more systems in place such that we are, properly testing the outputs. So, not necessarily pen testing, but very similar in the sense that, there's like a list of things that we can think of how we can break the LM in order to, try and reveal things, right? So that's one step. So that comes primarily around prompt engineering and how we can improve the prompt to not allow this from happening, to not allow someone to accidentally jailbreak by, typing in a language which we were not thinking about. And suddenly this foreign language can expose the internal workings of the prompt. But then there's the other part where it's about how do you then it's a more traditional form of within the software development lifecycle is what data do you actually expose and are you putting in the right permissions in place to prevent certain confidential data from being accessible. So this is even before the point where the LM kind of like depending on the use case, the LM needs to access the information, and if you don't allow them to access that information, then you don't have to worry about that information being leaked out. That would be one way of like just preventing it from even being exposed to begin with. And it has to pass through the usual loops of checking the permissions and so on, whether that user has the right to access it. So, there's that part as well. So I think the most tricky part is when we actually use all this confidential data as part of the training model. So then, I haven't heard of anyone really doing that yet, but I think that would be the most difficult part about trying to not expose certain confidential information that gets leaked out. So in most cases, it's kind of like the LLM, the model itself, you kind of like just contains the reasoning capabilities and the data sits somewhere else. but don't quote me on that. But this is roughly what I've gathered.
Yeah,
Okay, hope that
thanks
answers this
for
question.
the answer there. Actually, I have one more. Considering that there's like some issue about someone stealing some prompts through the like prompt engineering and stuff. Like there's I think there's a couple new that I heard about OpenAI. There's so many different ways you can break the system basically. So
Mm-hmm.
yeah, I'm curious about like it is better to do it in like let's say within a dedicated cloud, basically it's like somewhere that is like stored there, or is this something better if it's locally? So which one it will be better to run this?
Because it really depends on the use case. Yeah. So it really depends. So I think primarily if it's government related, you tend to not want to, you tend to want to keep everything on premise. Yeah,
Okay, all right, thanks.
yeah. So yeah, it really depends on the use case of the data that you're working with, the consumer information, and yeah, there are different solutions out there for that. With basically the more sensitive data is, the more difficult it is to deploy such an AI solution.
Okay, thank you, Albert. I'm looking at the time, so we have like 9 minutes left. So I think that's enough time for one or two more questions. If anyone else in the audience has any questions.
I mean, you guys have questions, maybe I can ask you guys. And I can't see the audience, but um, I don't know. Like, can someone? Is there any show of hands of people who have learned something and feel like they want to try this out?
Yeah, there's like a few. There's a few. There's a few. There's a few in the audience, including me.
Okay, that's good to know. Okay,
I think
I take it.
if there's no more questions from the audience, then I'll just kind of take the opportunity to ask the final one. um,
Sure.
so allow me to, if I can, and this is kind of like a conversation between two persons at this point. I kind of want to pick your brain once more, Albert, because this is actually very interesting for me. So just now you've mentioned about like confidential data, right?
Mhm.
And how you have to be careful with the models that you use so that people, when they try to jailbreak it, the AI doesn't accidentally spit out confidential data. So I
Mhm.
was wondering, is there like a way to make it so that the AI has been trained on or has access to a number of databases, but depending on whichever is the user that logged in and used that AI, you can kind of check the permission and lock which data it's pulling from. So what this means is, let's say if you're just a level one security person and you want to read up on some data, sorry, you're using this AI, it can only access database A and database B. But let's say you're an admin, you're like a CEO or something, you can get access to all database data in all databases. Is that something that's like possible? So like a dynamic permission based sharing or permission based AI. I don't know what's the word. Like,
Mhm.
hope that makes sense.
Yeah, it does, and that's perfectly possible. Yeah. So I think even in the realm of non-AI related things, that happens. Yeah. So um, because essentially the moment you log in, we already know what you can access and what you cannot access, without even before you start using the AI. So yes, we can definitely do that.
Okay, that's
Hmm?
cool. That's cool. Okay.
Yeah.
Yeah, that actually answered my question. I think if there's no more questions from the audiences, then I suppose we can kind of call it early, right? So it's like 6 minutes ahead of our time. So thank you, Albert, for your time here. I think a lot of the audiences have learned a lot, me included. So we really appreciate you kind of coming down here, well, virtually, to
Mhm.
present about AI. I think with like well, it's been 2 years now since. Wait, no, wait. ChatGPT was this year. Yeah, AI has kind of taken the world by storm. So everyone's kind of jumping ship, right, and jumping the bandwagon. Sorry. So
Yeah, that's right. Yeah.
well, what you've
Yeah, even myself, sorry, even myself, yeah, I think we've only started on this journey since I think February this year. So we've only been at this for about the last 9 to 10 months. Yeah. And a lot of people are in this area now, similar kind of like experience level because it was just so fun. It was just exciting. Everyone just wants to do it, you know?
it's like kind of creating your own personal assistant. Now I'm just waiting for the
Yes.
day that Siri finally has like an AI integration. Then all of a sudden we'll have a very smart personal assistant. So just waiting on that. Apple's just gonna do one of those things eventually next year or something. But yeah, thank you, Albert. I won't keep you any longer. Panel finish. So thank you for the audience for attending, and yeah.
Okay. Thank you very much. Yeah, if anything, just reach out to me on LinkedIn or GitHub and I'll get back to you. Thank you all. Bye bye.